Okay, I'm Jadi, and on the last part of our logging tutorials, I will talk about journalctl. This is the newer kid in the block. It's part of the systemd. You've seen how systemd is. No. Systemd journal. You've seen how systemd is eating all the Linux. It started with init, it's new init system. Okay, acceptable. Then it says, I'm the new cron with its timers. Then it says, I will manage all the services. Now it's managing the boot, managing the NTP, and it's managing the logs using its journalctl module. This is kind of against Unix philosophy. In Unix, we want small tools which do one thing perfectly, not a huge bloated thing which does everything. Because in this case, we have a single point of failure. We have this problem that we will be locked in one system. Systemd doesn't create its logs in text format, so you need its own specific command called journalctl to read these logs. So you cannot use your friendly grep in a script. You have to use journalctl to find things, and in general we are not very happy about it, but it's working fine, and we are professional system administrators. We will learn everything which needs to be learned. And many people doesn't know systemd much. I believe after this session you will know more than most of your friends about using journalctl, and it's very useful. It's powerful. Let's have a look. As I've told you, the general command is journalctl, and it's a service. So you can say systemctl status, I think it's called systemd journalctl. Yes, it has its own logs here. It's active and running, it's loaded and everything. You saw in one system I have rsyslog and journalctl at the same time. Some of them are reporting to this rsyslog, some are reporting to journalctl, and they are talking with each other. rsyslog is sending its data to journalctl, journalctl is sending its data to rsyslog. And again, I have that strange arrow. I have to find out where it comes from. Anyway, our command is journalctl. It shows all the data in journalctl from the beginning of the logs. In my case, it's from June 14th. The system booted up. This was a Linux version, blah. And you can see the time when it happened. I will push the down arrow going down. It's too slow for such a thing. Even the second is not changed. I will go with page down. Again, too slow. I have to go to the end of it. This works like a less command. So I can go with capital G to the end, or with this character to the end, and with this to the beginning. So shift will shift and that one to the end. This is the end of my logs. Difficult to read. I can go upwards, I can go downwards, I can type a question mark and search backwards. For example, I can say NTP. There's no NTP here. NTP. Okay, mount point NTP. Fair enough. On that specific date, I had one. I can push N for the next. I can go with slash search forward. Say search for test. I was testing for writing the book. So it works kind of like a less. With Q, I exit. This was too much logs. Difficult to read. Let's have a look at the configuration. Less etc systemd journal dconf. There are lots of configurations here. The cool thing is all of them are commented out. So I'm using the whole default configuration, but you have the default configurations here. For example, it says forward to syslog Yes. So whatever journald receives forwards it to the syslog, and whatever syslog gets is configured to forward to journal T. So they are syncing with each other. TTY path is this one, the default one. All of them are default. If I want to change them, I will remove this and will change the value. We will have a look to this one later, but now everything is on default. As you saw, when I issue journalctl, it shows me lots and lots of data from the beginning of the logs it has to the end. And I always have to go with Shift G or this larger than sign to go to the end of it and search what I want. This is not very nice. So there are some switches. For example, -R will show in reverse, the newest on top, easier to follow. I don't like this, so I will do journalctl-E. Says okay, go to the end. To start it, but in the beginning, go to the end. I want to see the newest things for sure. Q. There are some other things too. For example, -F for follow, just like tail-F. If you're following something, waiting for some logs, you can say journalctl-F. Show me the last 10 lines and wait. If anything new rises up, show me. With Control C, I break it. There is -N, which says journalctl-N10, show me the last 10 lines only. And it doesn't go to your prompt. It needs some intervention. I have to say Q, okay, enough. Not very good. -K, show me only the kernel log, same as dmessage you saw in the previous sections. -B is fun and cool and will make you enjoy journalctl. You can say journalctl list boot. This is another one. It lists all the boots it has seen. It says, okay, 0 is the current session. -1 is the previous boot. -2 is the 2 boots before. For example, -6 is this boot on Thursday at 8 o'clock. And the last log I have from that boot is same day, 9:38. And I can check this specific boot with -B. So I used list boots to show me all the boots. And you see, list boots work, list boot work. journalctl understands some of these abbreviations. So I can say journalctl -B -6. Show me that specific boot. It says, okay, on 8/19/28, you booted your kernel. This was your Linux version. Again, I have this. Why? I think I'm pushing some button somewhere. So it says, on this time you booted the system was booting, it was the kernel version. You can see it when it does have the kernel ring buffer data from the message. And these were the things I was doing. The system booted up. All of these are coming from the kernel. Here, I'm going page up. Still kernel is booting, page down, page down, page down. And you can see at 8/19/28 kernel booted. Then I tried to bring up systemd. I tried to load this one. All the things you have from that specific boot. Shift G will go to the end or the larger sign. And at this time, I'm shutting down the system. So you can check one specific boot in systemd, which is cool. You can use -U to check one specific service. For example, you have the systemctl status. These are the services. For example, you have SSH. So you can say, I want journalctl, the unit SSH. It will show you only the SSH sessions. And you can say, I want them from the current boot. Forget about other boots. It's okay. On this boot, you have this SSH sessions, accepted password from Jody from this machine, for example. So you can check for one specific unit. You have lots of other facilities too. For example, you can say since journalctl, I want the unit SSH since yesterday. This is why journalctl and systemd are conquering the world. It's very easy to say which logs you want exactly. This is a little bit more difficult and needs more bash foo or Linux foo to reach. In older systems, you should be able to grep about the time and find in different files and this kind of stuff. But here I'm saying, okay, unit SSH since yesterday. And I can even say priority info. So it's okay, these are the info priorities. I missed a few of them. So this is much easier. You can say journalctl, whatever happened since 10 minutes ago. So okay, from 10 minutes ago, these happened. Or you can say from minus 10 minutes. Until minus 5 minutes. You can combine whatever you need and create whatever you want to do. You have a crash last night, this morning. You can say, I want to check from 01, this is hours, until 5 o'clock. Something bad happened here. Okay, on my machine, nothing happened here. If I go to the 10, I'm sure we will have something because I was up. So these are different methods you can use. You can say since and until. Give it a specific date and time, or give it only the time, or only the date, or say from yesterday, today, tomorrow, now, since 10 minutes ago, since minus 2 minutes, and other stuff. You can also use things like priority. -p info was working. You can also say, let me show you, journalctl priority equals info doesn't work. Man journalctl priority. You have to give it the numbers. It says okay, -p or -- priority. You should give these numbers. Emergency is 0, alert is 1, critical is 2, info is 6. So priority equals 6. Although no one does this, we say -p info. All the info ones, for example. Or you can give it journalctl, this specific process I'm looking for. Or this specific PID. Very easy to work with. As we had logger in rsyslog to send a manual log, here we have the systemctl-cat. But you have to pipe to it. I say echo, this is my funky log, cat it here. Pipe it to this one. And then I can say journalctl, give me the last 5 lines. This is my funky line, comes from unknown. I can say the priority is, I don't know, info. Okay, another one comes from cat, priority is, what happened? I checked the help. Okay, this one comes, this is comes from cat, and priority is info. If I check only based on the priority info, I also have the other one because I have info and higher. So managing, you have this. Yes. Okay, I was using this. Also, you can do with specific commands output. So I can say uname. systemctl-cat uname runs this command and uses output to log. If you have a script, this way you can log your output of your scripts in the system log and configure them to do something based on your needs. It says, okay, the output of the uname. You can also do silly things like ls. This will give you multi-lines, so you will get lots, multi-lines of the. Every line will be a new log in your journalctl. So you saw the systemctl-cat. Why this is happening? Once more. So you saw the systemctl-cat, which was working like logger command. Also there we had the logroatet, and it was rotating your logs, managing their size. Again, on the journalctl, we have binary files. You cannot just edit them manually or delete them manually. You need systemctl tools. And now I will speak about them. All of them are managed via configurations and a few tools. You saw this. etc systemctl journalctl conf. Here we had some configurations. For example, we said storage is auto. We said system max use is not configured. Let me talk about this auto first. Systemctl can do three things with logs. It can save them on disk, it can save them on memory, or it can do nothing. Just ignore whatever log you sent. Sometimes useful. You have a very small device without any memory and you just want to neglect all the logs. The question is why you are running systemctl there. Anyway, when the storage is set on auto and systemctl starts journalctl, it checks var log journal, and if there is a directory there, will create a directory there and will save all the logs inside that one. This directory is your machine ID. Every machine has a machine ID, which is a unique ID. So when the systemctl starts the journalctl starts, it checks var log journal. If this directory exists, it creates a directory or goes into the directory with the same name as your machine ID and saves its logs there. So if you boot the system, the logs will be here. If this doesn't exist, systemctl will keep the logs in the memory. And when you reboot, these are gone. This is the normal default method of storing logs. If this directory exists, it creates or enters the machine ID directory and creates its logs. So these are permanent. Otherwise, it saves them in the memory, and when boot, this is gone. This is the storage auto. If you want to override this, you can do with storage volatile. Force systemctl to save everything in memory, even if this directory exists. If you go with storage persistent, you're forcing to enter this directory. Even if this doesn't exist, systemctl will create it, will create another directory with machine ID here, and will save files here. Let me show you the machine ID too. It's cool. Cat etc machine ID. There is a file. Your machine ID is here. Every operating system, Linux, has this, and this is unique. Your host name is not unique, but this is unique unless you interfere and make it, copy it somewhere, for example. And I have this var log journal. This directory exists. I'm on auto, so journalctl checks this directory exists. It enters this directory. If it's not exist, creates this here, and persist are its files here. This is for system. This is for user with ID 1000, which is me. So each user has its own file. These are the new ones. These are the rotated or older ones, but we don't understand them because these are in binary. Anyway, back to our configuration. So you know about this storage and how it affects how you keep them. There are other ones like these ones. System max use. You can say, uncomment this and says system max use is 100 megabytes. So in maximum, journalctl will keep its files under 100 megabytes. You can go with 1 gigabyte, 10 terabyte, whatever you want. Works for you. By default, it's on 10%. So systemd files won't use more than 10% of the disk. You have another configuration, system keep free. It's very cool. You can say keep 20 gigabytes free. You don't need to be 20 G. So you are telling systemd that on this disk you are running, you are saving your logs. I need this much free space. If you exist, if you are still writing and the free space is less than this, don't write anymore. The default is on 15%. So systemd, if sees that you have less than 15% remaining disk space, won't write more logs. No. Still write logs, but will delete the older ones. You can also do with system max file size. What the size of each file? You can say 100 megabytes. Each file shouldn't be larger than 100 megabytes. By default, this is 1/8 of system max use. And at last, you have system max files at the end. You have the system max files. Don't create more than 100 files. These were starting with system. So these applied when your storage was persistent, or this file exists and machine ID created and the files were here. When it says system, it means for actual files on the disk. We have the same configurations, but starting with runtime. Runtime max use, runtime keep free, runtime max file size, and runtime max files. These work when your storage is on the memory. So two different configurations, which keeps your disk space safe. And there is one switch, few switches, which vacuums this. You want to manually remove older logs. You can say journalctl, please do a vacuum based on the time yesterday. Delete whatever log older than yesterday. You can also do it 10 seconds or 10 minutes, or if you want 10 months, like this. M is a little bit tricky because minutes and months both start with M. So M means minutes, months means months. But for example, for days, you can say 10D or 10 days. No difference. So you can do a vacuum based on time on the journalctl command. You can say journalctl vacuum based on time 1 year. Delete whatever older than 1 year. Or you can say vacuum based on size. Don't keep more than 100 megabytes at this action. Later, it will comply based on your configuration file. But at the moment, I can say reduce the file size to 100 megabytes or vacuum files. The number, I don't need more than 100 files. So this is how you manually remove older files. And the last part about journalctl, which is a useful one, I'm glad that it's in LPIC, is how to check logs from a crashed server. You have a server, okay, files are created normally in var, log, journal, machine ID. Here you have your files. This system crashes. On the old good days when we had text files, you were able to mount this hard disk on another machine, go and read your files. Easy. Or boot this system with a live CD, mount this drive, go to your logs and check them using less, grep, whatever. But you cannot do the same with the journal D, because files are not normal files. You need journalctl. There is one switch which is -d or -- directory. You can tell journalctl to read your files from this directory. So if your system is crashed, it's crashed, not booting up anymore, it's enough to connect your hard to another machine or boot it with a live CD, mount the previously var log journal machine ID on a new mount point, for example on MNT. You can mount it on MNT, and now you have your files here. Please note, your machine ID is your old crashed machine ID. So even if you go here, you will see the directory, but you have to check your machine ID file to see what is that. On your new machine, you will have a new machine ID. So you mount this here and just start journalctl with -d/mount var log and point it to this directory, and journalctl will read its data from here and you will continue normally. It is also possible to do with -- file and read only one file. For example, you move this specific file, you know Jody broke the system, so you have user 1000 journal, you move this somewhere and say journalctl -- file, read this file for me. And journalctl knows how to read it. Or you can even do a -- merge. Merge those logs into my own system. Machine ID is changed, you merge old logs into your new logs. You can also do a -- root, which is easier and says, here I have some journal D data. Go and read them yourself. This is useful and I'm glad that it's here. So you know about your logging now. You understood how the logs work, why we have a central logging system. You know about how rsyslog works, and you know a lot about journalctl. I mean, if someone tells you, we had an incident last night at around 3 o'clock, you know how to tell journalctl to show everything important on that specific time, or how to -f one specific unit and see if it's working fine or not, and other stuff. Teach your friends. Many people don't know journalctl in depth, at least even in this depth. This is not very, very, very deep. It has lots of features, but you know a lot compared to most of the people. And I will be glad if you introduce this channel to your friends and subscribe and everything. I'm creating this for free because I'm enjoying them. Thank you.